Okay, here we're going to look at variables. And all that a variable is a symbol, usually a letter, that represents a quantity that may change. Variables are usually where students start to have a hard time with math, because that's when you start introducing x's and letters to represent quantities. So for example, t may represent the time. So it may represent that t might be the number of years that go by, the number of years since 2010, and so on. H may represent the height of an object, and P may represent the profit of something. Okay, so suppose that T represents the number of years since 2005. So explain the meaning of each. So if T is the number of years since 2005, a T value of 0 would represent the year 2005, because you're 0 years since 2005. T equals 1 would represent the year 2006, because you're 1 year since 2005. T equals 10 would be 2015, okay, the year 2015, because you are 10 years since 2005. How would you represent the year 2010? Well, isn't 2010 5 years since 2005? So you would represent that year by saying t equals 5. So don't make it more complicated than it is. So question 2. Suppose P represents the profit in millions of dollars of a business in the year that is t years since 2010. What is the independent variable and what is the dependent variable? Well, this is something I wouldn't expect you to go too crazy on trying to think about it. But essentially what you want to think about is, does the profit the company make depend on the year that you're in, or does the year depend on the profit? Well, generally what we look at is, as time goes on, the profit may go up and down, right? Or the profit may fluctuate. So generally there, what you're saying is the independent variable is the time that goes on. Because as time goes on, things go up and down, in this case profit. Okay, so the independent variable is t, okay, or the number of years since 2010. The dependent variable will be p, the profit. Now if that doesn't make any sense to you, what I would say for this class is right now, anytime you have time as a variable, that's generally going to be your independent variable, like your x. The only time you'd have to be careful with that is, suppose you're looking at something like 100-yard dash times in the Olympics, or 100-meter dash times in the Olympics, where the output itself is like the time in seconds, and then the input would be the year that the people ran that fast. Okay, so if both units are timed, then you have to be a little more careful. But generally speaking, time will be like your x value or your independent variable. So how would you represent the variables as an ordered pair? Well, if your input is time, that would be t, and then p would be the output or the dependent variable. So explain what each ordered pair means. So 0, 3, that would mean that the t value, the year since 2010, is 0, and then p, the profit, is 3. So what does that mean in the context of this question? 0 years since 2010. So in 2010, the profit was 3. Well, profit is given in millions of dollars. So the profit was $3 million. Okay, so 1.5. Well, 1 year since 2010. So in 2011, the profit was $5 million. Okay, so you can just write that down. Okay, then in part D, the following table gives the year and profit. We're going to rewrite the values as ordered pairs TP, and remember that T is the year since 2010. So in the year 2010, the profit was 3 million. So as the ordered pair, that was 0.3. Okay, so go through and do the same thing for each of these. And I'll put the answers up just to save time. So pause the video if you need to. And then I'm going to give you the answers. So 0, 3, 1, 5, 2, 7, and 3, 9. Okay, and then what we're going to do is we're going to graph the ordered pairs and label the axes. Okay, so on our graph, what's different now is that when you were graphing x, y values, there was no context to the question. So now we know that T is the number of years since 2010 and P is the profit in millions of dollars. So we can't start the graph at year 0 and then say year 1, 2, 3, 4 all the way to 2010. So we take advantage of the fact that we said, okay, T equals 0 represents the year 2010. So rather than putting the year down here of 2010, we're going to put 0 years since 2010. So the very first value on the bottom left will be 0. And then we have 2011. You can put that in the next one, or you can skip one and put one that's separated a little. That's up to you. And then 2, 3, 4, and so on. Now remember, what those represent are the number of years since 2010. Okay, and that's your T value. Okay, and I'm kind of drawing axes in there so you can see it. Okay, so that's the T axis. And again, what you got to be careful of is that 0 represents the year 2010. So you do not put the actual year down here because they told you that T is the number of years since 2010. So if you were to write 2010, the actual number 2010 down here, that would mean that your 2010 years since 2010, which would really mean the year 4020. And that is not what you want. Okay, to look at the vertical scale, we have the profit in millions. So we have to go from 3 to 9. So we do have 9 tick marks going up the side at least. So we can just say every tick mark is worth 1 million. So I'm going to say 1 and then 2, 3, 4, and so on. I'm skipping 1 each time just to make it a little better looking and it's not as cluttered. But once I put that second tick mark as 2, that meant the first one had to be 1. Okay, so I say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that is the vertical axis, which represents P, which is in millions of dollars. Okay, so to create a scatter plot, we have the point 0.03, which is right here. And then we have the point 1.5, which is right here, and so on. So I'm going to put the answer up so you can see what the scatter plot looks like. Okay, so when you're all done, it should look something like this. Okay, so it's pretty straightforward, but it is a little bit different than the other just plotting x and y's because of where you put the axes. So I should have mentioned before, when you're plotting the t values, 0, 1, 2, 3, we don't need any negative t values. So that means you don't need to be on the left-hand side over here, any negatives. Same idea for the profit. You have profits that are positive. So that means you only need 0 and higher. So that's why we put the axes in the bottom left like this. Okay, if you put an axis in the middle, you'd be wasting 3/4 of the graph, of the grid. And you don't want to do that. Okay, the second page to look at. The second example gives the average price per barrel of crude oil for various years, adjusted for inflation. So rewrite the table as ordered pairs of the form T, comma A, where T is the number of years since 2010, and A represents the average price per barrel of crude oil. And we're going to create a scattergram for T, comma A. So we have the years since 2010. So 2012 is 2 years since 2010. So that means that your t value there is a 2, and then the output is 92. The year 2013 is 3 years since 2010, and then the price of crude was 96. Okay, so you go through and finish that off. And I will point out, I didn't try to trick you on this one, but you do have to make sure that you're not lazy and just say, okay, 2, 3, 4, 5, 6, 7. Make sure that you have the years given that go along with the numbers that you're putting for t. I could easily skip the year 2014 and just put 2015 there. You just have to be careful not to put 4 there if it was 2015. Okay, so just be careful with that. Okay, so I'll put up the answers for the ordered pairs, and then we're going to create a scatter plot. I'll put those answers up at the same time. When you do the scatter plot, we need positive t values for the year since 2010. So again, you're going to be able to start at 0, and then 1, 2, 3, and so on. And then we only need positive average price in dollars. So that means you have to make a scale up here, going up the vertical side. Now in this one, notice how the lowest value is 37, the highest is 96. Obviously you can't go by 1. You can't say 1, 2, 3, 4, 5, and so on. So you need to figure out a scale that works. So what I suggest, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 boxes going up the side, and essentially you have to fit up to 100. So 96 is pretty close to 100. So if you take those 10 boxes, divide it into 100, so from 0 to 100 is 100 values you have to fit in. That'll give you 10. So if you let each box be worth 10, then your scale will fit in there, and all the points will be able to fit. Okay, and this is the average price in dollars. And that is the A axis. Okay, so doing these scatter plots, it does take a little bit of time and a couple examples to understand it. But just make sure you look at those examples. Okay, so now we want to plot the points. So I'm going to pause the video and put the answers up with the scatter plot. Okay, so here's the ordered pairs, and then the scatter plot looks something like this. Okay, you have some points that are very high up here, then the last 3 are much lower. Okay, so that's what the scattergram would look like. When you do a scattergram, make sure you label the axes. Okay, and that'll depend on what your variables were. Okay, so T is the number of years since 2010. Make sure you write that down here. And then A was the average price, so make sure you put that on the vertical. Okay, then the last thing to mention here is sometimes a variable's values may have a large jump or gap between 0 and its lowest value. It may be convenient to use a broken axis in these cases. So I just found a generic graph here that it gives you the water temperature over 14 days. So the first day, second day, third day, fourth day, and so on. And then the temperature. Now notice that the lowest temperature was about 20 degrees Celsius, and the highest was maybe 27-ish or 26, somewhere in there. So that's only fitting like 7 values, but those values are in the 20s. So if you're just plotting points between 20 and 27, if you try to fit an axis in from 0 to 20, that's a lot of wasted space. So what you can do is do what we call a broken line axis or broken axes. And that's just putting a little squiggle in the axes, and then you can start wherever you want. Now in these other axes, so in the last example, I didn't do that. I started at 10, and then 20, 30, 40, and so on. So once I put that second tick mark to be 20, that meant the first one had to be 10, and you have to stay consistent. So every tick mark is worth 10 from that point on. On a broken line axis, this one, if they start at 20, and if they had tick marks here, they can make the tick marks be worth however much they want now. So if they say 20 and then the first one is 21, the next one would have to be 22 and then 23, 24, 25, and so on. Okay, now if they use 20, 25, 30 for their tick marks, they're using every tick mark being worth 5. Okay, so my point is that once you start labeling the tick marks with an actual number of how much each one is worth, then you have to stay consistent. We couldn't say the first one is 20, this one is 25, and then this one is 50. Okay, you can't do that. Once you start the scale, you have to stay consistent. Okay, that's it for that video.